Now we will look at the formula for magnification, the various aspects of looking at the value of magnification, and application of magnification for lenses and for mirrors. We need to take some situation to begin with. So let us look at a concave mirror where there is an object kept. So this is the object, this one is the image, right? This is a ray parallel to the principal axis, which upon reflection passes through the focal point. This is a ray hitting the pole of the mirror, and upon reflection it comes back at the same angle. These two rays on their own, they happen to meet here, and therefore we call this as an image. And now you know what kind of an image this is called. The rays have met on their own, therefore we call it as a real image. Now in this is the object distance, which is denoted as u, and from this point to this point, this is the image distance v, the focal length of the mirror, let us call it as f. We know that the mirror formula is 1 by f is equal to 1 by v plus 1 by u. This is the mirror formula. As of now, it has got nothing to do with magnification. What we are going to look at is a formula for magnification. Now the formula for magnification, if you write it in terms of object distance and image distance, that is u and v, there will be one formula for magnification. If you write it in terms of the object height and the image height, then there will be another formula for magnification. Formula for magnification, which is denoted as m, is given by height of the image by height of the object. If this seems to be a bit confusing for you to remember the notation, then don't worry, you can also write it as height of the image by height of the object. It is not a rule across the globe that we have to use only capital H for the height of the image. Most of the textbooks actually use that, therefore I have also used it. But otherwise you can call it as height of the image by height of the object. This is like the definition of magnification. Of course, at this point I would like to add that there is something called as a linear magnification and there is something called as an angular magnification. All that am I speaking about now in the context of the exams that you have to write at this level is only the linear magnification. Angular magnification is something that you will have to worry about once you come to 12th class. So till that time, this is it. But the same magnification, when quoted in terms of object distance and image distance, it will be m is equal to minus of v by u. Now in many books it is rightly given as minus of v by u, but the way they present it is slightly different, and many students also out of laziness they tend to write this as minus v by u. This kind of notation I don't really advise you to follow that. The reason is you see a minus very close to the numerator. Today you will remember that this minus was there in the formula. What about 3 weeks down the line? Then you will promptly forget it, right? This minus was supposed to be outside the brackets. V and u should be untouched. They should be left as it is. The moment you write minus here, today you will remember, 2-3 weeks down the line you won't remember and you think that this minus is because of sign convention and then you mess it up. So don't use this approach. Don't use this approach at all. Minus of v by u. This is a formula in which we had to apply sign convention to figure out where the image was. We have done a session on that. I hope you have seen that. And this is also a formula where we have to apply sign conventions. This is also a formula where we have to apply the sign conventions. So all the equations that you are dealing with in ray optics are essentially what should be called as general equations. Equations in which sign conventions are not incorporated already. You have to apply the sign conventions and then see what kind of an answer just emerges out of that. That's it. You don't have to alter anything else apart from correctly incorporating the sign convention. So minus of v by u. This is the formula for magnification. Now let us look at values of magnification. Suppose I write a few values of magnification. Suppose magnification, a few values are, let us say 2.6 and then 1.8, 1, minus 1, minus 3.1 minus 6.9. So suppose we have a set of values for magnification: 2.6, 1.8, 1, minus 3.1 and minus 6.9. If a question is asked as to out of the given values, where is the magnification the largest? Many students tend to make a mistake and they mention 2.6 because plus 2.6 seems to be much more than minus of 6.9. That is wrong. Magnification should never be seen as one particular quantity when you look at these numbers. Magnification always has two aspects to it. One is a sign and the other one is a number. Sign should be considered separately, number should be considered separately. Sign has got its own importance. The sign tells us whether the image is erect or whether the image is inverted. And the number tells us whether the image is enlarged or whether the image is diminished. So both should not be clubbed and viewed as one unit. We should never do that. Right. So, just a second. I think I missed the letter here. It should be enlarged. Right? Yeah, mistakes do happen. So this is erect and inverted. That information is given by the sign. Enlarged and diminished. That information is given by the number. Now when you look at it, this 2.6 should be looked at as plus 2.6. It means the image is erect and it is 2.6 times the size of the object. Plus of 1.8 plus erect image 1.8 times the size of the object plus 1. Object is of the same size as that of the image, but plus here means upright or erect. Minus 1, same size as that of the image, but it is inverted. Now imagine minus 3.1, inverted image, 3.1 times the size of the object. So this itself is greater than this. Minus of 6.9, minus doesn't make it a small number, minus only tells that the image is inverted. And for that matter, we are speaking of a real image here, because it is the real images which are inverted. So it's a very good thing actually. So minus of 6.9, inverted image, therefore a real image which is 6.9 times the size of the object. Right? So this is how magnification should be looked at. Plus or minus sign separate and the number separate. The overall information that you get is by combining these two ideas. This is how magnification should be looked at. Now let us combine all these ideas of sign convention, mirror formulas, lens formulas, magnification, and take a look at few sums that have been asked in the board exams pretty recently. Right? That's what we will do now.